All right, let's talk about one of the most famous, messiest, and honestly most spectacular science demonstrations out there, elephant toothpaste. We're going to break down the wild science behind this amazing foam volcano. So, let's just dive right in. So have you ever seen one of these things erupt and just thought, whoa, I have to try that? Well, you are in exactly the right place. We're going to show you how to whip up this foam volcano using stuff you probably already have lying around the house.
Okay, first up, a volcano of foam. So, what is this stuff, really? What's going on?
At its core, it's just a really fast chemical reaction. The whole point is to create this huge, warm, foamy eruption that just bursts out of its container. I mean, it literally looks like toothpaste getting squeezed out for a giant. And get this, the reaction even creates its own heat.
All right, Section 2. Let's set up your home science lab. You ready to give this a shot yourself? Here's what you're going to need. And don't worry, I bet you have most of this stuff in your kitchen or bathroom already.
Okay, here's your ingredients list. First, you need some hydrogen peroxide. Yeah, the stuff you get at the pharmacy is perfect. Grab some regular dry yeast from the baking aisle, a little warm water, and some dish soap. Oh, and the food coloring? That's totally optional. Just makes it look cool. And trust me, you'll want a bottle for the reaction and a big pan or tray to catch the glorious mess.
But hey, before we get started, let's talk safety for a second. It's super important. You should definitely wear some safety goggles and gloves. This reaction is what scientists call exothermic, which is just a fancy way of saying it makes heat. The foam that comes out is going to be warm, so please don't touch it right away. And, of course, if you're a younger scientist, make sure you have an adult helping you out.
Okay, Section 3, the step-by-step reaction. We've got our safety gear on, so let's make some foam. You'll be surprised at how easy this is.
Seriously, it's as easy as 1, 2, 3. Step 1, activate the yeast. Just mix about a teaspoon of it with 2 tablespoons of warm water. Step 2, get your bottle ready. Pour in about half a cup of hydrogen peroxide, a good squirt of dish soap, and a few drops of food coloring if you're using it. And now for the fun part. Step 3, pour that yeast mixture into the bottle, take a step back, and just watch the magic.
All right, Section 4 is all about unlocking the chemistry. So you've seen what happens and how to do it, but why does it work? Let's get into the science behind the foam.
To really get this, we need to talk about a key player called a catalyst. Think of a catalyst like a super efficient coach for a chemical reaction. It jumps in, gets everything moving way faster than it normally would, and then it just steps back out, totally unchanged, ready to go again. It's pretty amazing.
So, who's the superstar catalyst in our experiment? Well, it's an enzyme in the yeast called catalase. This little biological machine is the secret sauce, you know? It's what turns a really slow, kind of boring process into that awesome, foamy eruption we love. When you zoom way down to the molecular level, this catalase enzyme is just unbelievably good at its job. It has one mission in life. Find a hydrogen peroxide molecule and just snap, break one of its oxygen atoms right off. And it does this over and over super fast.
Okay, so let's follow the whole chain of events. You've got hydrogen peroxide, right? It's naturally unstable, meaning it breaks down by itself, but really slowly. Now, when we dump in the yeast, the catalase inside speeds that whole process way up. It rips the H2O2 apart into 2 things, plain old water, H2O, and a single oxygen atom. But these single oxygen atoms, they're not happy alone. So they immediately find a buddy and pair up to form oxygen gas, or O2. All that gas tries to escape, but, aha, the dish soap we added traps it, creating millions and millions of tiny bubbles. And that, my friends, is our foam.
Next up, more fuel, bigger fire. So, you want to make your foam volcano even bigger, even faster? Well, just like with anything, it all comes down to the fuel. The strength, or concentration of your hydrogen peroxide makes a massive difference. That standard 3% stuff from the drugstore, it gives you a nice, steady flow of foam. It's great. But if you get your hands on a higher concentration, like 12%, whoa, that's way more fuel packed into the same space. It gives the catalase so much more to work with at once, and the result is a much quicker, way more dramatic eruption.
Hey, remember how we said the foam gets warm? Well, there's a science word for that, exothermic. All it means is that the reaction is releasing energy, usually as heat. When you feel that warmth, you're literally feeling the energy being released.
And that heat isn't just some weird side effect. It's a core part of what's happening.
See, all chemical bonds store energy. So when our little catalase enzyme goes to work, breaking the bonds in millions of hydrogen peroxide molecules all at once, all that stored energy gets released at the same time. That huge, sudden release of energy is what you feel as heat. That's why the foam volcano gets warm.
So we've gone through the ingredients, the steps, and the science behind it all. So what's the big takeaway here? What's the one key thing you should remember from all this?
It's this: a catalyst, like the yeast in our experiment, can unlock the hidden energy inside a simple molecule. It turns a super slow process into something spectacular and incredibly fast. The catalase doesn't add anything new. It just unlocks the potential that was already there, turning something that would normally take weeks into an event that happens in a flash.
And that leaves us with one last question to chew on. We've just seen a reaction that releases heat, right? An exothermic reaction. So what about the opposite? Can you think of any reactions you see in everyday life that actually absorb heat, making things around them feel colder? Something to think about for your next science adventure. Thanks for joining me.